Hello everybody, my name is Ananya Kamraj. So today I'm here with another subject, discrete mathematics. So let's look into the topic. So today we're going to discuss about combinations and repetition. So let's look into the contents. So first we're going to study about what are combinations, and then let's move on to what are repetitions, and then an example of combination with repetition. So basically, the combinations with repetitions of n is taken as an element of k, in which k are the different groups of elements which can be formed from the n elements. So allowing the elements to repeat themselves and considering that two groups differ only if they have different elements. That is to say that the order does not matter. They are represented as C of R n, k. So let's look into what exactly is the definition of combination. So combination is nothing but it's a way of choosing items from a set such as the order of selection doesn't matter. It is unlike permutations. So in smaller cases, it's possible to count the number of combinations. Combination refers to a mixture of n things taken k at a time without repetition. To know the combinations in the case where repetition is allowed, terms like k selection or k combination along with repetition are often used. For instance, if we have two elements A and B, then there's just one way to select the two elements. We select both of them, that is selection of both A and B. So what is repetition? Repetition is nothing but if we choose a set of R items from n types of items where repetition is allowed and the number of items we are choosing from it is essentially unlimited. The number of selections which are possible in that given set of items is represented here. It's nothing but n plus r minus 1 divided by r. So let's consider a basic example where a set of A contains the elements A, B, C, D, and E. The different combinations with repetitions of these elements are as follows over here. Combination with repetitions of 5 taken elements in ones A, B, C, D, and E. So combination of repetitions of 5 elements can be taken as before AD, AB, AC, AE, BC, BD, BE, CD, CE, and DC. But now the groups with repeated elements can be taken as AA, BB, CC, DD, and EE. Similarly, combination with repetition of 5 elements can be taken in threes as ABE, ABC, ABD, ACD, ACE. The next is ADE, BCD, BCE, BDE, and CDE. But now they can also be grouped with their repeated forms such as AAB, AAC, AAD, AAE, BBA, BCC, BBD, and so on. So combination with repetitions of 5 elements can also be taken in 4 as ABCD, ABCE, ABDE, and so on, up to the related number of groups which are repeated. And then it can be also in the form of AAAB, AAAC, BBBA, BBBC, and so on. And also, the combinations with repetition of 5 taken elements in 5s also could be formed. And apart from what we had earlier learned was that there's a different formation of elements over here. For example, if you take A, B, C, D, E, it can also be repeated with A again, another included with B, C, D, E, and so on. So you can see that in this example, it can see the number of combinations with repetitions which have taken place for n elements over here. So you can understand here from the formula, by seeing that CR of that is nothing but combination with repetitions of n elements and k elements is taken as n plus k minus 1 by k, which is nothing but n plus k minus 1 the whole factorial divided by n minus 1 the factorial into k factorial. So that's the basic formula which you're going to apply for, the further problems over here. So to know all the combination with repetitions of 5 taken elements in threes, we're going to use the formula we get. That's, for example, let's take an element of n as 5 and k as 3. So now we are applying the above formula which is mentioned here. So combination with repetitions of 5 and 3 can be taken as 5 plus 3 minus 1 divided by 3. It's nothing but 5 plus 3 minus 1 the whole factorial divided by 5 minus 1 the whole factorial into 3 factorial. So 5 plus 3 is nothing but 8. 8 minus 1 is nothing but 7. So it becomes 7 factorial. 7 factorial divided by 5 minus 1 is nothing but 4. 4 into 3 factorial. It's given here. It's nothing but 35 is the given answer. So let's take another example over here. There's a bag which contains 7 balls, which are numbered from 1 to 7. Without looking, a ball is taken out and the corresponding number is noted. So, and the ball is returned to the bag. This action is performed 3 times. That's nothing but to say that there are 4 number of combinations over here. Now, let us see how many sets of numbers can be obtained by means of this procedure. If there are in total 4 numbers, which are noted in total here. So the development of the problem states that we have n is equal to 7. That's nothing but the number of balls from 1 to 7, which are chosen here. Next, we take k is equal to 4 because the numbers are written already in that ball. Now, also the elements can be repeated because as you leave the ball again inside the bag, you can see that the ball backs next time, which is general. Next, also it can be seen that the order does not matter. So it is a question of a combination with repetition, and therefore, according to the expression, it is given previously, saying that the formula C of the combination with repetitions of n comma k elements can be given as 7 plus 4, that's number of balls, which is present in the bag respectively as of the conditions mentioned in the previous slide, minus 1 divided by 7 minus 1 the whole factorial into the number of k, that's nothing but 4 factorial. So now we can see that 7 plus 4 is nothing but 11. 11 minus 1 is nothing but 10. So the 10 whole factorial divided by 7 minus 1 is nothing but 6. 6 into 4 factorial. So 6 and 6 factorial gets cancelled. So 10 factorial divided by 4 factorial is nothing but 210 is the answer. So thank you for watching my video. Please do like, share and subscribe to my video.